In this lecture, we will give you an introduction of how to do things that take time in JavaScript. That is, of how to use the asynchronous features of JavaScript. Before we do that, let's look at good old Python, and let's consider how to do something that takes time in Python. We have here an example. This function does an HTTP call. Let me call the various steps 1 when we enter the function, 2 when we do the call, and 3 when we print the result. So what happens roughly in Python is something like this. We enter the function, we execute the call, and this is a network call in general. Well, here it's to localhost, but it could be to an external service. So these network calls take a little bit of time, just like reading from files or doing many other things can take time. So here we have to wait for the result. And the operating system that underlies Python never wants to be stuck and doing nothing. So essentially here puts us to wait, in a wait state in which our thread is no longer active. Here the operating system will do other stuff. Okay? So it will activate other threads. Maybe your computer is busy servicing other web requests if it's a server, and if it's your own laptop, maybe it's, I don't know, giving the control to some other browser tab to refresh your Gmail window, whatever it's doing, okay? So after some time, the call will come back, okay? And so from 2, you will proceed to 3, okay? And you will print the result. So this is a sort of somewhat intuitive way. So there is the hidden part that is the fact that your computer is doing multitasking. It's called multithreading, right? Multiprocessing. It can do other stuff in between. But from your logical point of view, you have essentially done 1, 2, and 3 in order, okay? And so in particular in Python, you can read the code in the same way in which the execution happens. If you read the code from top to bottom, that also tells you in which order the statements will be executed. We will see that this is no longer true in JavaScript. Let us see now how the same thing is done in JavaScript. In JavaScript, there is the following idea. Every browser tab has a single JavaScript thread. And this single JavaScript thread wants to do the following all the time. It wants to take an event. An event can be a mouse click, you pressing on a keyboard key, you moving the mouse in or out of a region, or maybe information that comes back from the network and becomes available to JavaScript. So there is an event, and what you do is you want to process the event without ever stopping, without ever waiting for anything, okay? Then, when you are done with the processing, you go back and you go wait for the next event. So you wait for an event, you process it, and you go wait for the next one. But while you process an event, you never ever want to stop. So in order to do a network call in this way, you do as follows. So let me give the numbers again. Here is 1 before the call, and here is 2 once we have the result available, okay? And here we have 3, which is after the call. And in JavaScript, what you do is this. You have somehow triggered this to happen, perhaps by loading the page or by clicking on a button. We don't care so much about that. You do 1, and you don't wait. You're telling the network call, look at how it is written. You are saying jQuery get, which is the way to do the call. You are saying, please go get this URL, okay? And once you do it, please let me know and call back this. So we will tell you in a moment what this does, okay? But so you essentially start the network call. Here, you start the network call. Then you immediately go to 3. Okay, because you have just started it, you don't wait for the result. You go to 3, you do this log, and then you stop, like here. And so you stop waiting for the next event. So there is one thread that essentially does this. Okay, and then, whatever else stops. In the meantime, the network will try to fetch the information, okay? When the network finally has reached the information, it will generate a call to this function here. So this function is called a callback function, precisely because it is called back once the results arrive. You specify to do something and say, hey, please, when it's done, call me back at this function. So once the network is done, later on, the callback will happen, okay? And so this function R will be called, and code 2 will take place, okay? This is a function R, and so the output will be produced. The second log will happen, after which you stop. Okay, so this is how things happen in JavaScript. Okay, and so the real difficulty of JavaScript for beginners, and even sometimes not for beginners, is that in JavaScript, reading the code from top to bottom does not tell you the temporal order in which things happen. Okay, because if you look at this piece of code, the portions 1 and 3 happen immediately, essentially, one after the other right away, without any wait. Whereas the portion 2 that is sandwiched in between will only occur at the end of the network call. Okay, so if we were giving timings to these instructions in some imaginary system, this could happen at time 0, then this, would be very fast at times 0.0012 seconds, perhaps, and this is step 2 instead could be at 0.63 seconds, because it took 63 hundredths of a second in order to get the reply from the network. Okay, so this gives you at a picture the classical way of doing things in JavaScript. You never ever want to wait. Whenever you do an operation that can take time, what you do is that you do the start of it and you specify the callback function to call when the function terminates, when the action that takes time terminates. Okay, this is called programming with callbacks. Okay, and this enables a single JavaScript thread servicing an event loop to be able to be in charge of all the network communication and things that occur in your tab. I find this programming with callbacks very intuitive and pleasant, but this doesn't seem to be the general opinion, and so people have invented another mechanism to do exactly the same. And the other mechanism is called promises, and the library we will be using in this class, Axios, for network communication, uses promises. So the idea is very similar, and in fact it's realized exactly through the same mechanism, but the code looks slightly different. The code looks like this. Okay? You see, the act of starting the request is this, and instead of specifying a callback function as an argument to the Axios get, we specify it via this .then construct. The .then will take as argument the function to be used when the activity terminates. So the idea is very similar here. Again, the main thread will have a flow of computation that is for. Then you do the Axios get will be started, and after these there will be 6, and you stop or you do whatever you need to do next, and then when the process finishes when the network is done, it will do this callback that will cause this activity 5 to happen, and then you stop again. Okay, so this then function, this then processing takes in general 2 arguments. In fact, a function to execute if your activity finished successfully, and a function that you use if the activity finished unsuccessfully. Here, for simplicity, I'm focusing on successful completion of the activity. Okay, so in a way, it is just a similar syntax for the purpose. Okay, instead of specifying the callback directly in the access get, you specify it as an argument to the .then. Now, one technical part that is interesting is that this piece alone, you see, it's a self-contained piece. So this piece actually generates what is called a promise. The way to read this code is that access.get of this URL will give you a promise. And if you have a promise, you can call .then to do something when the promise is fulfilled or fails. So when you do then, you can in general specify two functions, f and g. One is for the success, and the other one is for the failure of the action. Okay? So promises are essentially containers for unfinished stuff. The action of doing an access get gives you a promise, and you can specify via then the functions to be executed if the promise is fulfilled and if the promise fails. Okay? And these functions f and g will be done later on when the outcome of the promise becomes known. There is yet a third way of doing the same thing, and that is to use async functions and await. We create an async function. The crucial point about an async function is that it returns a promise. Okay? So this function will return a promise. It's not a function that can ever return a value, an async function. It returns a promise that can contain a value in the future. In this case, we are not using the return value. But inside this async function, we can do the following. We can do a console log that we are starting our asynchronous call. And then we can say let r is equal to await Axios. So we can essentially have a statement await that is only allowed in async functions that will take the promise delivered by Axios.get and wait for its resolution. So this function here generates another promise. Okay, this thing generates a promise, like before. Generates a promise. Okay? This await awaits until the promise delivered by this Axios.get is fulfilled, and then it puts the result into R. And now we can log R. Okay? Now, what happens when we run this code is that we will see in the logs that 7 will be done first, and then R will have to wait for this promise to be delivered, right? So when we start this function, this returns a promise. We don't do anything with the promise, and we do 9 immediately. Right? And only after the network is done will 8 be executed. Okay? So in this way, the advantage is that within the async function, you can actually read code top to bottom. So this is kind of nice. On the other hand, you cannot read all code top to bottom, because between these two statements here, the async get will be started, but the console log will happen before, okay, the line 8. Let's take a look again at our original function that took a callback. This is done via jQuery, so the jQuery.get gets two arguments. It gets the URL that you want to access, and then it gets a callback function to be called when the result is available. So this is one style of doing things. Then we have seen an improvement using promises. Axios.get generates a promise, so you can say .then, and you can specify what to do when the result is available in the .then part. Okay? So now we have broken up the task in two. Axios.get generates a promise, and the promise is so-called thenable, that is, you can call then method on it, to specify the callback. And so the question arises, okay, how did the Access people do it? I mean, jQuery came first, and the way of using callbacks to code in JavaScript came first. Suppose we have only jQuery available to us. would we be able to write an equivalent to Axios? And the answer is yes. What we have to do is to learn how to create a promise. Okay, Axios.get returns a promise to which we can then apply the then function. So how can we create a promise? Well, we can do it as follows. The promise is created here via this new promise function. This new promise, that it goes from here to there, gets as argument a function of 2 parameters. This is a bit involved, admittedly, but you feed to the promise a function that contains, in turn, a function resolve to be called in case of success and a function reject to be called in case of failure. Okay? And so what we do is this. We do our good old jQuery get, and we give it a callback that when it gets the result, it will call resolve R, because resolve is a function to be called in case of success. Okay? In this case, we don't do anything in case of failure. We don't specify what to do, for simplicity purely. Okay? So in this way, we generate a promise P. Once we have the promise P, we can attach a callback to it. I mean, not a callback, but we can then it and specify what to do after. Okay? So when we build the promise, this code gets started, and then we attach a then to it. And here is something interesting, by the way. The promise, we don't know how long it will take to build it in code, right? Maybe there is a lot of bookkeeping around. But JavaScript guarantees that if you create a promise in this way and you then specify a then, even if by any chance the network call was super fast and the result was already available, the then part would still get executed. So the promises give you this guarantee that what you specify via the then always gets done. Okay? And so this would be an equivalent way of essentially using the Axios style based on jQuery. We use jQuery to build a promise, and then we then the promise to get the computation done after the network call is fulfilled. Okay? And you can create your own promises. There is this syntax that takes a moment to get used to. You build a promise by specifying a function of 2 arguments, a function resolve to be called in case of success, and a function reject to be called in case of failure. These 2 functions, resolve and reject, are essentially the continuation, so the callbacks that are wrapped inside the promise. So this is all very good, but we want to see it in action. So here I have created a JavaScript file that contains exactly the sequence of calls that I have outlined before. The one using callbacks, the one using promises and the Axios library, the one using the async, and the one using the promise that we create. Okay? So I call this file index.js, and in index.html I do the following. I load jQuery because it's not standard. Okay, it's not loaded by default in Python Web. And then I load my index.js. And one thing you have to know, and we will come back to it, but one thing you have to know about web pages is that web pages execute material in a very greedy way. As soon as something is available, they run it. So as soon as this index.js is actually loaded, it will get to run. Okay? And so, and by the way, this call, promises get val, that I call each time. Promises is just the application name, and get val is the endpoint. This simply returns an OK. It doesn't do anything else. Okay, so there is no interesting processing. Actually, I could put a sleep here, but I don't think it's needed. Well, for the fun of it, let me do it. I can import time. Okay, and here I can say time.sleep 0.1 seconds. Okay, so we delay a tiny bit due to sleeping. And I can restart these. Okay. And then I can go load the page. The page is admittedly not very interesting. Okay, but I want to keep an eye on the network, on the console, where all the logs will come out. So if I reload this page, that's the sequence. Okay, so you see that I think we need to compare these with the code to make sense of it. Okay, so let me put it side to side with the code in JavaScript. You see, we see 1 before the callback. Then we start this jQuery call that doesn't finish yet. And so we do 1 and then 3. Okay, and the 2 will be done only much later. The 2 here will be done only down there. Okay, so we do 1 and 3, then we do 4 and 6, again the 5 will come later, then we do 7 and 9. Okay, so we start the async call, but this 8 that is after the await will occur only much later. So from 7 we go to 9, from 10 we go to 12, and then the results start coming back. Okay, if we went to the network tab, we could see that that there is a bit of delay. How do I scroll this window? Okay, sorry. Okay, so you see this is a time taken by these various requests. I can see things a bit poorly here because it's all, but these are the times taken by the various requests, right? So there are these getVal requests initiated by jQuery and Access. There are 4 requests. Okay. And so coming back to the console, so these 4 things happen very quickly. This initiation of the 4 activities happen very quickly. And then slowly the results start coming back. Okay. So the first that comes back is 2. Okay, so this comes back first. There is no reason why this comes back first. It's a bit at random, really, given the behavior of the network. Then the other thing that comes back is 11. So it happens to be this one. Okay, we have essentially initiated 4 network calls roughly at the same time. Now they're gonna come back roughly at the same time, and it's a bit arbitrary which gets done first. So in this case, this gets done first. Then 11 gets done next, this one here, okay? Then there is 5 that gets done, so then this one comes back, at 5. And then the last one that comes back is the one at 8. And there is no reason. In fact, if I repeated these, the order might be different. I actually have no idea what will happen. Let's try it, okay? So let's remember, this was 2, 11, 5, 8. Now I clear it, I do it again, and I have no idea whether it will be the same. 2, 11, 5, 8, yes, it's the same again. So, there is not enough noise in my system to generate another order, perhaps. But you are not assured of the order in which things come back. By the way, this also tells you something, that if you want to do multiple requests in parallel in JavaScript, it's quite easy. You simply write them one after the other, exactly as we have done here. Here we have amused ourselves using different ways of doing the request, to give you some flavor for variety. But if you start multiple requests, you're essentially sending them out all at the same time. And then once they come back, you will process them one by one. You could be doing tens or even hundreds of requests at the same time. Modern browsers, to avoid overloading the network, because it's not efficient to actually have a huge number of requests open, have a limit on the number of requests that you can have open at the same time. I don't remember what the limit is. It's about 50 to 100. I don't really remember. And you can maybe even change it in browsers, okay, to obtain optimal performance. But so in Python, doing requests in parallel would not be incredibly easy. I mean, it would not be too difficult, but you would have to use the threading library to create parallel threads, then spawn the threads, do them, have them do the requests, and then, wait until they all finish. In JavaScript, it's actually much easier to do stuff in parallel because you don't really do anything in parallel. You just initiate the activities one after the other, and then each activity will do its own callback when it terminates. In this class, in order to do network calls, we will be using this way, okay? So the way using the access library that returns a promise, and then we use a then to the promise, okay? This is just because this is an easy style to use, and it will be our favored for the class. The jQuery library is optional. We don't generally will use it in the class. The way of using asynchronous functions is fine, but it's also not the main way we will be using. So if you have to remember one way to do calls, remember this one.